let's take a look at real numbers. Real numbers include rational and irrational numbers. First, let's look at rational numbers. Okay, rational numbers can be written as a fraction with an integer numerator and a non-zero integer denominator. So rational numbers can be written as a number over a number, and this one can equal 0. So examples of rational numbers are 5, 1.5, 0.3 repeated, and 0. Let's see how these match up with this definition. So it has to be able to be written as a number over a number. 5 can be written as 5 over 1. Can be written as 10 over 2. And a lot of different equivalent fractions with an integer over an integer. So this one is a rational number. 1.5 is the same as 3 over 2. Integer over integer. 0.3 with the line over it means that this goes on forever. So 0.3 on forever. Well, this is actually the same as 1/3. So even though this decimal goes on forever, this is a rational number. And the number 0 be written as 0 over any number. 0 over 1, 0 over 2, 0 over anything. So this is rational. Okay, the numerator can be 0, but the denominator can't be 0 in the definition. So this one is a rational number. Okay, so now we'll go over irrational numbers. Irrational numbers are simply numbers that are not rational. So they can't be written as a fraction with an integer numerator and a non-zero integer denominator. Two examples would be square root of 5 and also pi. Okay, the square root of 5 is 2.23606, and that decimal keeps on going on. Pi is 3.14159, and that goes on forever. So because these decimals go on forever, and they do not repeat, these are irrational numbers. Okay, here we have a decimal that goes on forever, but it's repeating. So this is rational. Also a rational number, for example, could be 0.27 if the 27 is repeating. So if it's repeating, it's rational. If it just goes on forever with no pattern as far as repeating, it's irrational. So you could simply you can tell quickly if a number is rational or not if it's a whole number, or if it's a decimal that ends, or a decimal that repeats. Irrational numbers are numbers with decimals that do not end. Okay, now I just want you to note something about rational and irrational. This is used on a lot of different tests to try and trick students. They'll ask which numbers are irrational, and they might put 3.14 as an answer choice. So right away you think to yourself, 3.14, that's pi, and pi is irrational. So this is irrational. But 3.14 is a rational number. Okay, because 3.14 isn't exactly pi, it's just what we use as pi sometimes. 3.14 is a decimal that ends. See, it stops. It doesn't keep on going. So this is rational. Pi continues forever. That is irrational.